So today we're looking at what's called a box plot or a box and whisker plot. Kind of a funny name, but you'll see why it might be called a box and whisker plot. So it's another form of representing data, just like a bar graph, a histogram, any kind of line graph can represent data, so can a box plot. You probably looked at pie charts as well back in junior high, but not this. Okay, so here's what it looks like or what it means. In a set of data, the median is the middle data value and therefore divides the data into two equal-sized groups. That's nothing new. We knew that. 50% of the data is below the median and the other 50% is above. That's why it's called the median. That's the definition. The median of the lower half and median of the upper half. So once you've divided it, the median of the lower half, that's going to be called quartile 1. Okay, so if you think of quarters, dividing something into quarters, you're dividing it into 4 parts. So quartile 1 is basically the median of the first half of the data, and quartile 3 is the median of the second half of the data. Really, the median is the same as quartile 2. But we never call it quartile 2, we call it the median. Okay, so when we calculate those 3 values, Q1, median, and Q3, we have divided the data into 4 parts, 25% each. Okay, so we're going to look at a box plot, what it is, and it shows the data divided into 4 equal-sized groups. So we need, for a box plot, we need those 5 things: lower value or lower extreme, first quartile, median, third quartile, and highest value, upper extreme. Okay, so let's take a look at this data. Given the following set of marks, determine the lower, upper, median, all those 5 things. We've got a chart there. Take a look at the data. First of all, how many are there? So there's 3, 6, 7 in each row times 5, so there's 35 data values. Okay, and if you take a look, we put them in order for you. So I'm not going to put them in my calculator. If they're in order, median is really easy, right? So 35 is an odd number. So there is a middle data value, right? So if we divide this by 2, we get 17.5. So that means, there is no 17.5 data value, right? So it would be the 18th, which means we have 17 data values to the left, 17 data values to the right, and the one in the middle. So the 18th, that's going to be 14, 15, 16, 17, 18. Okay, 71. Okay, so lower extreme 35, upper extreme 94, those are the easiest. And then now we look at the first quartile. Okay, so we've already used the median, and so we have 17 data values below it. The median here, so that's again an odd number. We divide that by 2, we get 8.5, so we want the 9th value. Okay, so there's 7 in each row, so this would be the 9th value. Okay, and then you could go 9 from the other direction, 7, 8, 9th value. So 62 and 80. Okay. What's wrong?
I was showing him the value and then you just put it on the board.
All good? If there was an even number of data values to start, then your median would be the average of the 2 middle ones. Okay? And then your first quartile would actually include that first half of the data. You haven't used that data value yet. So we don't use this in the lower or upper medians, quartiles. Okay, so here's an example of a box and whisker plot. Notice how there's no vertical axis. So there's a horizontal axis, okay? And really, we don't necessarily start at 0 for whatever reason. Probably should, well, shouldn't say that we should start at 0, but do a little squiggly. This is representing marks in class. So it is probably a good idea to write a label. Math marks, I'll call them. Okay. And so there's your 35, your lower. First quartile is 62. Median is 71. This is a little bit, when we did it on the computer, it's a little bit off there. So it should be a little bit higher. And then 80, titch off there just because of the way it's on the computer. That's quartile 3. And then 84 is the upper extreme. Okay, so this is where you draw a box. So thinking about this, this is 25% of the data, so is this, so is this, so is this. Okay, so it's a fast way of sort of comparing how concentrated the data is. This is obviously 25%, but it's pretty spread out compared to these parts, particularly this one. So that means there's a lot of people scoring between 71 and 80, right? Same number of people here, but spread out. Okay, each part would have the same number of data values. So here's the steps to do it. Draw a scale that begins at a value less than the lower extreme, ends at a value greater than, makes sense. Mark the 5 values, lower, first quartile, median, third, and upper. Draw a box from the first to the third, and try to use a ruler on this, a straight edge. Horizontal line between those. There was actually a question on the IB exam, the math IB exams this past week on box and whisker. So even though it's pretty straightforward, even though you're in grade 10, it could end up showing on your IB exam. And then we talked about the 25%, each part of it. Okay, so in any box plot, what percent is below the median? Well, 50%. That's what makes a median, right? Below the first quartile, well, that's 25%. Remember, each of those divides it into 25% parts. Above the first or lower quartile, well, that's 25% you've got there below. Now above would be 75%. In the box, 50%. Each whisker, 25%. And then below the third or upper quartile is sort of like this one. So 75%. Okay, so we're going to make a box and whisker here. It says we've got another class, exams in another class, or another exam. Lower, first, median, third, and upper. Okay, so we want to 45. So the scale's already been done for you. So 45. So if you're asked to do this, then you would need to have a ruler that marks it off. Note that scale has to be accurate. But oftentimes, if we ask you to do something, we'll give you a line with scale markings, like equally spaced markings, and then you put whatever values you think are appropriate, just to save you that time, right? So 56, 70, 76, and 87. Okay, let's see if my board's cooperating. So we're going to do a straight line at the ends. Oops. Okay, so straight lines. So from there. Okay, so that's your whiskers. Then I'm going to go below here with a straight line to try to draw my box. And then vertical lines at each end and through the median. Okay, so it's pretty close. And this. Okay. So, next one shows the data for another set of marks for another class. Take a look at the difference between them. This is way spread out compared to this one. Certainly the middle 50% is much more spread out than the middle 50%. Now, you would want to check to see that the scale is the same before you start comparing them, because maybe it could be squished in or expanded out, but they do line up. Okay, so there's a much more variety of results in this second class here compared to the first one. Okay, so here, lower value, again, try your best to estimate. This one looks a little bit more easier to read. Okay, so we can also get our calculator. Remember, I showed you yesterday when you do the one variable stats, it will give you the lower value, the quartile 1, the median, quartile 3, and upper value. Okay? Now, for a chart of values like the first one we did, they were already in order. It would take longer to use your calculator. But something like this, it might be easier to use your calculator because this is a frequency chart. So this means that we have 4 tens. If we were to write this out the long way, this would be 10, 10, 10, 10, then 8 15s. Right? You don't want to have to do that. I mean, you could, but you could think through it. What you could do is add up the frequencies and go from there. But let's practice on our calculator. So get your calculator out. And remember, these are statistics. So we're going to go to stat and just edit right away, number 1. So you're going to get those lists from yesterday. You're going to want to clear them off. Okay. And first column, always you want it to be your data values, your X values. So that's the first row in that chart. So 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay. Then we want the frequency of each of those. So 4 tens, 8 15s, 13 20s, 20 25s, 28 30s, 25 35s, 18 40s, 15 and 8. Okay. So quit out of that. And then remember, we're still dealing with stats, so go to stat, and we're going to calculate. Calculator's going to do the work for us. And the very first one is one variable stats. Even though we've got 2 lists in here, it's not 2 variable stats. You don't never use it in high school. Okay? So only the one variable stats. And check L1 is your data list and frequencies in L2. So don't have to change anything in mine. Uh-oh. So anytime it gives you a dimension, go to. And something's wrong with my list too. Could be that it didn't read my entry here. Yeah, take a look. I've got an extra one. Okay. So your calculator, this is going to help you. Always go to and see what's missing here. So maybe I'm missing 10, 15, 20, 25, 30, 35, 40, 45, 50. So 8, 4, 8, 13, 20, 28, 25, 19, 15, 8, and for some reason I put 6. Delete on that and quit out of that. Now it goes back to my one variable stats. I can just press enter on that. Okay. All right, so the horizontal scale is done for you. You can take a look here. The minimum X value is 10. Okay, so for the dot, even if you have a ruler, keep it all on the same line. So a dot for that, quartile 1 is 25. Cursor down, median is 30. Cursor down, quartile 3 is 40. And the maximum is 50. Okay, so do your whiskers. Do your box. Okay. It should look something like that. So you can see very concentrated in this here, this 25% of the data, as opposed to above 30. Okay, any questions on your calculator? You're going to want to be able to use that one variable stats to get this information. Okay. Okay, so then sometimes we have what we call outliers. So data values that are not even close to what the rest of them are. So we call them outliers. So sometimes data sets include values that do not seem to fit with the rest of the data because they're too low or too high. Guys, do you have questions on your calculator? So these values are called outliers. It's funny, when I first moved here, I used to teach in Ontario and moved to Calgary, and they're teaching this in a course. It wasn't an IB course, but it was part of the curriculum. And I put it on a test, like what do you call this value? And a couple of students put an outrider. And it's like, outrider? That was from a stampede event. And I thought, oh, I've never heard of that before. But obviously I'm in Calgary now because in Ontario, not really part of the day-to-day language. Anyway, it's outlier. It lies outside the majority of the data. So how do we figure if there's an outlier, or what is the definition? That's what we're going to look at here. So fill in the chart. Take a look at this set of data. It's very similar to the last set. Okay, it is in order. It's 35 values. So, so there's your middle. Okay, so your median is 71. And so 62 is the first quartile. Lower is 25 now, which is quite low. Upper quartile is 80. Upper extreme is 94. Okay, because it's the same 35 data values. Same number of data values. Okay, so one mark, 25, seems to stand out when compared to the others. To determine whether we would call 25 an outlier, here is the information, and this is what was asked on the IB exam and the grade 12s, as I mentioned to you before, when they did this in grade 10, it's 20 IB, it was during COVID, and they were supposed to learn it, but they, you know, so some of them had to review and some of them forgot to review. So in any case, this definition, first of all, the interquartile range is basically the difference between these two. So it's the length of that box in a box and whisker. So it's Q3 minus Q1. So in this case, 80 minus 62 is 18. Okay. The range of a set of data, if you remember back to junior high, is just the highest minus the lowest. Okay. For a set of data, range for a function is obviously all the y values or dependent values. So if a data value is less than the lower quartile, okay, the first quartile, minus 1.5 times the interquartile range. So IQR is interquartile range. So we want to calculate what 1.5 times that is. So in this example, 1.5 times 18 is what? Half of that 9, that's going to be 27. So then you take your lower quartile, which is 62, and subtract 27. Okay? And so 62 minus 27, what's that? 35. Okay, then look, are there any data values less than 35? Well, there is, right? The number 25 is. So that is an outlier. We can check the upper. Doesn't look like it will be, but the upper we take 80 and add 27. So that's 107. And all of the values are less than that. We can change our box and whisker a little bit to identify that outlier. So what you would do is your line, your whisker, would start at the lowest value that is not an outlier. Okay, so if you take a look back up here, 52 is the next in line. So that's 52, right? And you don't join it up, and you indicate an outlier with a star, okay, or an asterisk. And then you do the rest the same. Okay, so that's how you would identify that. So if you're asked to do a box and whisker, you should look and see if there are any outliers, and then graph it accordingly. Now, what's kind of neat is your calculator will graph it. Okay, so in this case, we're going to enter the data in L1, so we've got to go back. So we do have to actually enter this data. Bit of a pain, but that's okay. So stat, edit, clear off L2, clear off L1. Okay, enter 25. So just go through, enter them. It really doesn't matter what order you enter them in. hopefully I've entered them correctly. You can see I'm on the 36th entry, so that means my 94 was the 35th, which I know there's supposed to be 35 numbers. And then I'll maybe just scan through. They're all 2 digits, and it looks like I have 2 digits on all of those. Okay, so we can do our one variable stats, but we're not asked for that. We're going to get it to do a box plot. Okay, so stat help. Okay, and oh, sorry, wrong entry. So quit out of that. So stat plot, did that yesterday too. So second y equals, because we're going to graph something. So graphing a function, we use y equals. Graphing statistics, we use stat plots. Okay, second y equals. Now yesterday we did a histogram. Mine is still turned on. Maybe yours is as well. So I'm going to leave it on, but I'm going to go down to type. Okay. Now there's 2 choices there. There's one that has a little dot afterwards and one that doesn't. Let's do the one with the dot because that's going to give us any outliers. Okay, so enter on that. Then XList is in L1, and then frequency there isn't. So yesterday we had to delete it. You might have to put ones in. Let's see, I can't remember. Yeah, it's not going to let me go out of that. So I'm going to put 1 because there's 1 of each of those data values. Okay, and now what's important is your window as well. So go to your window, because I've still got a window from yesterday, 235. Those data values aren't even in it. So you can go, say, from 0 to, what was the biggest number on this? This was Mark's, right? Where was it? 94, yes. So let's go 0 to 100. And you can go up by 5s. Now, why min? Doesn't really matter what you do because there is no really y. So I'm just going to keep it -1 so maybe I can see that horizontal. And then I'm going to keep it as 8. We'll see. We can change it. See what happens. Okay. So there you go. Okay. If you press trace, it's at the 52, that's the end of your whisker. Then quartile 1, quartile median, quartile 3, maximum, and then we can go back, and the minimum is 25. Okay, now if I change my window, my Y to max, let's change it to like 4. It's just still going to put it at that point on your screen, okay? Doesn't really care about the Y. But that will show you that there's one outlier. All right, and that's it, actually. Yeah. One thing it does note here, you can graph multiple box plots. They will go one below each other on the screen, so you can plot up to 4 at the same time. If you wanted to do a comparison, right, the scale would be exactly the same horizontally. All right, so that's it.